today's discussion we are going to see about amplitude modulation. So before going to see amplitude modulation, we will discuss what is mean by modulation. The process of impressing an low frequency information onto an high frequency carrier is called as a modulation. So to have a deeper understanding of what is mean by modulation, let us take an example. For example, if you want to throw a paper for a larger distance, if you throw a paper alone, it will it can be thrown only up to a certain distance. But if you want to increase the distance of throwing a paper, if you crush the paper around a stone and if you throw it, it can reach a larger distance. So now here your paper is the message and your stone is your carrier. So now we are going to transmit your with the help of the stone you are going to throw a paper at a larger distance. So like this, our information is the message signal. We are going to send the information over the high frequency carrier. So there are different types of modulation: amplitude modulation, frequency modulation, phase modulation. So in today's discussion we are going to see about amplitude modulation. So what is mean by amplitude modulation? Generally any wave will have three parameters. One is amplitude, next one is frequency, and next one is phase. So if we are going to vary the amplitude of the carrier with respect to the information, then it is called as an amplitude modulation. So amplitude modulation is the process where an amplitude of the carrier is altered according to the information in the message signal. So it is the most simplest and earliest form that is used in the transmitters and application, as you can see, CB radio and aircraft communication. So next we are going to see about how we are going to modulate. As you can see, your modulating signal is your message or information signal. So this is a low frequency signal and the carrier is your high frequency signal. So usually the frequency of the carrier will be high when compared to your message signal. And now this is your modulated signal and this is the expression for your AM modulated signal, and we can see in the later class how we are going to obtain a modulated wave from the message and the carrier signal. So now what is an M here? Your M corresponds to modulation index and your AC is the amplitude of the carrier and cos omega ct is nothing but your carrier waveform. So how to obtain an modulation index? As you can see from this waveform, this is your amplitude modulated signal and the envelope of your amplitude modulated signal carries your information. So AC into 1 plus M into M of t will be your envelope of your message signal, and AC into 1 plus M into M of t into cos omega ct will be your amplitude modulated signal, because the carrier is going to carry your information. That information is in the form of amplitude variation in the modulated signal. So generally your amplitude modulation is a non-linear process because you are going to mix up both message and carrier and you are going to apply and are going to get an amplitude modulated wave. So generally it is a non-linear process, and with this non-linear process you will have both sum and frequency component at the frequency. So totally your AM envelope will contain three frequency components. One is your carrier frequency component and other one is lower frequency component, that is sum of your carrier frequency and message frequency, that is FC plus FM, and lower frequency component, that is difference between your frequency component FC minus FM. So next we are going to see how to measure the modulation index for an amplitude modulated wave. So modulation index is generally a term that is used to describe how much an amplitude variation occur in a modulated wave. So as you can see, this is your amplitude of the carrier, and with this as a baseline your message will be running around the CC line. So as you can see, the total maximum amplitude will be EC plus EM and minimum amplitude will be EC minus EM. Respectively, this amplitude will be EC plus EM and this will be EC minus EM. So this is the maximum amplitude variations. So as you can see, you can write the formula as M equal to EM by EC, where EM is the maximum amplitude change of your modulated signal and whereas EC is your constant amplitude of your carrier, because we are going to vary the amplitude of the carrier to carry the information of the message signal. So how much your amplitude of the carrier is getting changed is represented by the modulation index term. So your EC is your amplitude of the carrier and EM is the maximum change that occurred in the modulated wave. Suppose if you have a signal that have different, if your message signal consists of many frequency components, then how to calculate your modulation index? You should calculate modulation index of each and individual frequency component, and then you have to square and sum up, and if you take the square root of your result, you will get the modulation index of your entire signal. So next we are going to see about, as you can see, your AM frequency component modulated wave will have three components. One is your carrier component, another one is upper sideband component, another one is lower sideband component. Your upper sideband component will consist of a range of frequency from your carrier FC to the highest frequency, that is FC plus FM, and your lower sideband will comprise of frequency from FC minus FM to FM. So your amplitude of your LSB and USB will be M into EC by 2, where M is your modulation index. As you can see, this is the spectrum of an amplitude modulated wave. From the simulation result window, as you can see, the frequency of your message signal that you have used is 500, and as you can see from this window, your frequency of the carrier is 4000, and as we have already seen in the previous slide, the frequency of the lower sideband will be FC minus FM. So your FC is 4000 and your FM is 500, and if you calculate 4000 minus 500, it will be 3500, and if you calculate your upper sideband component, that is FC plus FM, it will be 4000 plus 500, it will be 4500. So this is your frequency spectrum of our amplitude modulated wave. So from this, if you want to calculate the bandwidth, the entire range of frequency from FC minus FM to FC plus FM will comprises your bandwidth. So if you take, this will be FC minus FM to FC plus FM. So if you calculate, the total range of frequency will be 2 into FM. So the bandwidth of your amplitude modulation is 2 into FM, where FM is the maximum modulating frequency. Suppose if your modulating signal consists of many frequency components, you should take the maximum frequency component. So your bandwidth is generally given by 2 times of FM. Next we are going to calculate power, because power is an important parameter in any transmitter. So as we can see, the final expression of your power is Pc into 1 plus m square by 2. As you can see, for AM transmission, originally a carrier will have some power. In addition to that power, your sidebands also add power to the total modulated wave. So your total modulated wave will always have a power greater than your unmodulated carrier power. So this is one main drawback of your AM transmission. Thank you.